Damen einreihen oder? Fein. Ladies, Gentlemen.
Sind wir schon live? Ja. The decent way to start an online event is by asking, are we live? Welcome everyone. Ladies and gentlemen, again it's a pleasure seeing so many of you here today. There might be more people coming in, streaming in as we speak because, of course, the other panel was a little late. It's a dense day, we have a tight schedule. My name is Peter Schniering, I'm founder of Future Cleantech Architects from Remscheid. And we're very honored and pleased to co-host today's event with our colleagues and friends from the United Nations. And I would like to give the word to my co-moderator tonight, Vanessa.
Good afternoon, everyone. My name is Vanessa Völkel. I'm the deputy head of the UNIDO Investment and Technology Promotion Office in Germany, which is situated in Bonn. And we are hosting all events today, and especially the award ceremony later on. And I'm really happy to have this as a side event today here in Wunderschmiede. So welcome on behalf of the United Nations Industrial Development Organization. Wishing you a good discussion.
Thank you, Vanessa. And as as Vanessa has pointed out, we're covering a number of topics today, which are not so easy to bring under one roof, if you like. We've come across very interesting aspects from Toyota Motor Foundation, from E.ON, the large German utility, from a startup perspective, as well as people who are advising the process in the first panel on breakthrough innovation. How can we push innovation? And now we're very pleased to have this high-level panel here, exceptional panel, coming all the way from the Netherlands and from France and from Remscheid to this place. I will not introduce them. I would just like to stress, please make sure to network as much as you can following the COVID-19 rules. But there'll be, as you know, there'll be plenty of time, more people pouring in. There'll be plenty of time tonight at the MK Hotel, before the ceremony starts at the theater. And please make sure to interact and create new products, new projects if possible. But really, make sure meetings have taken place here in Wunderschmiede already by innovators who might collaborate, large organizations, small organizations. Without further ado, I'm just introducing the moderator. Why are we targeting industry? Because industry is so hard to decarbonize. Part of our work, or one of the largest part of our work as Future Cleantech Architects, is decarbonizing hard-to-abate sectors. Industry, cement, steel, aluminum. All these fields where you need massive amounts of energy to get the product, and where sometimes you have emissions you cannot avoid just by powering the process through renewables. But the process itself is releasing carbon dioxide or other greenhouse gases. So this panel is supposed to cover industry, and the moderator, who was so kind to take over this job in his very busy schedule, he told me he'd punch me if I say it again, but he's really, you want to reach Martin Heuer of Roland Berger at 12 at night, and the line is busy because he's still speaking to somebody. So he's an old friend of mine. We used to work together at Roland Berger. We were in projects in Finland and other countries, and he's a very experienced energy sector guy with an impressive track record in utilities, Energieversorger, and currently working on a lot of projects, difficult industry projects. And because Vanessa and I will have to leave a little early to prepare the main event in the Theo Otto Theater, he was so kind to say, I'll moderate. So without further ado, Martin, you have the floor. Thank you so much for joining us, and thank you everyone for coming in here so numerously.
Yeah, thank you for the very nice introduction and, well, parts of it. No, thank you very much, Peter. Thank you very much, Vanessa. Great venue, great audience, great initiative. It's truly an honor to be here among with these great panelists. So thank you very much for that. Before we start the discussion, I thought let's, so to speak, give it the opportunity to create a common mindset here of what it's all about. And first of all, it's great to convene in person, actually, after so many months of not doing that. That feels really good and feels really human. I have the obligation, I cannot stand up. This is prohibited, and it's tough for a consultant, I must say, so I will stick to my chair here. Before we start, a common mindset, and for doing that, I would like to take you on a little journey by stepping back from the problem that we're going to discuss and zooming out. And zooming out from ideology, from interests, even from solutions. Just let the problem as it is. And if we zoom out, and I mean zoom out like really high, what do we see? We see planet Earth from outer space. This is what we see. In the year 2021, bang, 2021 already is in mindset. And shows a limited view. So we take even 2021 back. What do we see? We see this planet after 4.5 billion of years, after the first sunbeam came down to Earth, after 65 million years when there was this awful storm in the afternoon and stones came from sky instead of rain and mammals took over from dinosaurs. Back 150,000 years when we sort of mastered fire, 50,000 years back when we mastered language, and an astonishing 150 years of accelerating firing things that were formerly already dead, and we deliberately call it fossil fuels. So this is where we are, without any mindset. And what is so tremendous about this phase in time? If we look on it on a cosmic time scale at eons, 4.5 eons, so eon, no hidden reference to any other company here. What did we do? We did a tremendous job in really pulling time or driving back in time by firing on an accelerated level through all these fossil fuels. So it's basically, I like to think of it as a time machine of what we have managed to do in the past 150 years. And why is it meaningful? Because it comes with a consequence, and the consequence is very straightforward. We change our atmosphere, the composition of our atmosphere. The atmosphere absorbs more energy than it used to be. And this has severe implications, and the implications are also quite straightforward. What is the material that we have most on the planet? That's water, and more energy in the atmosphere changes flows, states, and amounts of water. And this is basically what we are seeing: more rain, less rain, floods, dries, and so forth. And this is life-threatening for a bunch of creatures, including us, depending on where they are located. So, without any mindset, this is the situation from my perspective. Now, what is the sad thing about it? This is not really new. And when the General Secretary of the UN, Mr. Gutierrez, said, "Alarm bells are deafening," that is true, but it's really no news. And we have known that. At least we should have known that. But I'm more in the corner of we knew that. So, well, now what to do about it in terms of get it done. Not complaining, not panicking, just with a get it done mindset. And with a get it done mindset, I like to think about two things that are necessary. That is solutions and the willingness or the behavior to implement these solutions. Now, on the solution sides, is it easy or complicated when it comes to technology? Well, it's both. It's complicated and complex, but certainly doable, and the brightest minds on the planet are working on it. On the behavioral side, what is there the challenge? Well, the challenge from my perspective is we have, so to speak, on an individual level, we have interests that sometimes comply and not comply with the overarching goal of combating climate change. We have the same situation on community level, and we have the same situation on national level. And apparently, so to speak, in bringing together solutions and behavioral change, there we struggle. And otherwise, we wouldn't have had that problem for so long and wouldn't have known for the problem for so long. So a good example for that is actually, and unfortunately, German politics. Because German politics is always well-intended. We put a lot of, a huge lot of money in solar PV. And one could argue, and there are secondary effects, and we bought, so to speak, the lower part of the scaling curve for the entire world and so forth. And it's true, it is true. And I'm not looking back and, so to speak, judging. The only thing from today's perspective is it did not bring down the one KPI that counts, and that is CO2 in Germany, to a significant level. And same or similar effects we are seeing currently with the way we constructed the exit from coal. And therefore, we have a mismatch of intention and effectiveness. And that's a problem to be tackled. And this, as an overarching mindset, especially since we are in Germany today, my overarching question before introducing the panelists would be, can we make it better when it comes to the next wave of technologies, not exiting coal or PV, but with the next wave of technologies that is e-fuels, that is hydrogen, that is carbon capture storage, carbon capture utilization? What can we do better in order to be more effective when it comes to that single KPI that counts? Or will we be in 10 years in a position where we said, oops, we did it again, well intended but failed? And the other question is, what does it mean for heavy industry? And therefore I'm super grateful for our panelists today. What will it mean for the economy? What will it mean for the industrial structure in Germany? Will there be heavy industry in Germany? So very, very focused questions that I would hope to discuss with you this afternoon. And of course, I will not do that alone. Far from it. I will talk less, I promise. But let me give me the opportunity, please, to introduce our panelists of today. First of all, we have Magnolia. Thank you very much for being here. Magnolia is a chemical engineer by study. She promotes e-fuels in the light of, so to speak, policies that are needed to be taken. Magnolia's mission is super spearheaded with her organization. She is looking for the simple goal, the simple and super clear-cut goal of get as much CO2 out of the atmosphere as possible by changing narratives, by changing technology, by changing business models, by changing policies. And one thing that is very special and very nice in what I've found about her in reframing a problem is her view about hydrogen. Most of you, most probably, reconcile your chemistry lesson in 8th grade, the first one, when you were introduced to that tiny amount of hydrogen, and this introduction ended with a big bang. This is, so to speak, what many people have in mind. And therefore, if we discuss hydrogen pipelines and so forth, that's quite a thing if you really think about it, what the collective mindset about hydrogen is. Magnolia, she has a very different narrative and a very different viewpoint. That is, if you look at hydrogen, that's the most perfect molecule and the most abundant molecule in our universe. And if you think about it, hydrogen is just like a ballerina dancing through the table of elements. And I thought that was super inspiring. Then we have Karina. Karina is a commercial director at the European Green Hydrogen Acceleration Center. Karina is super literate in hydrogen, both green and blue. She has worked on new products for the energy transition at Air Liquide, so it's really, so to speak, coming from practice, and is working on projects for heavy-to-abate industries, from shipping to steel. So very much looking forward to get your views tonight. And then we have Dr. Roman Dietrichs, who's managing director, second generation of Divostal, a great company.
At least third.
At least third. Oh my God.
Or fifth, or 14th. Depending on how you count.
Okay, I got to go back to my research. Sorry for that. But I didn't want to make you elder than you are. No. So Dirostal is a steel producing company with 500 people, locally based here in Remscheid. At least, I will add that now on, at least 70 years of company history. This is what I have found. And what's the most notable thing about that is the apparent contradiction that is here. Energy-heavy industry, polluter, blah, blah, blah. This could be one mindset. The other mindset is these guys are actually producing the things that are pivotal and necessary to make green energy possible by producing the parts that are in windmills, by producing, so to speak, the parts that is in shipping. And so to speak, everyone who is, so to speak, light-footed arguing from a corner of this is good and this is bad should really reconsider that before making the having sent the next Amazon parcel. So I think that this discussion will be coming really out of real life. So thank you very much for being here. And I would just hand it over to you, and maybe you can introduce yourself, starting with Magnolia from a perspective. What is it about climate change? What are you working on? What have you learned during your work? And what is maybe an uncommon viewpoint that you would like to share, where everybody believes this is right, but you believe actually this is wrong?
Well, thank you very much for the introduction, and it's very exciting to be here today. Thanks. So I work at the Clean Air Task Force, and Clean Air Task Force has a program called Zero Carbon Fuels, and that's the program where I'm working at. And the program has as a mission to accelerate the decarbonization of Europe through the deployment of zero carbon fuels, and we do that through engagement with industrial players, with industrial stakeholders, with academics, with institutions, and obviously with policymakers as well, and through public advocacy. So that's the program that where I'm working at in a nutshell. So some of the things that we can say, some myths of in the area of hydrogen, we don't think of e-fuels that are currently being used right now, but if you think about the refining industry, at the moment the refining industry is burning a percentage of hydrogen, so it's not something that we are not doing. We're doing it right now, but we're not doing it because it's economical, but it's because it's too expensive to recover that hydrogen. So in terms of talking about safety and handling of hydrogen, the industry has solid and very well established procedures, safety procedures to handle hydrogen, and we are doing it on a routine basis. So that's what I wanted to mention.
Thank you very much. Carina.
Yeah, hello, Carina Kasten. So I work for InnoEnergy. InnoEnergy is a public-private partnership, and we're mainly funded by the European Union. We have the mandate to accelerate innovations in the energy sector in Europe, and we've recently, last year, established the European Green Hydrogen Acceleration Center. So we're focusing only on green hydrogen. Prior in my role I was looking also into blue hydrogen, today it's only green. And the goal here is to help hydrogen projects to accelerate and de-risk and make them bankable, because today hydrogen projects in general are not really bankable. So this is, I think, one first, let's say, big learning. Because green hydrogen is too expensive. That's what you always hear when you compare it to existing solutions such as natural gas, etc. And that also, I would say, is one of the myths, because in our, let's say, acceleration center, what we're trying to do is we're trying to look at hydrogen from a value chain perspective, which means we don't see hydrogen as a goal. No, we need to install like 40 gigawatts by 2030, but we see it as a mean to decarbonize products. And here also we come to the point of, the industrials that are actually producing products for us. If you go throughout the value chain and you get the end products that you're trying to decarbonize, that's when you can try to make them bankable. That's what we believe. Or you can close the financing gap through subsidies. And that's a bit our approach, let's say, this value chain approach. And when you look at, for example, hydrogen being too expensive, which is one of the myths we believe that is out there, it is still valid. Yeah? But when you look at end products, for example, we're looking at steel, and there are certain projects when you look at, for example, the ton of steel and how much it would actually cost to decarbonize it, right? Say for flat steel products, and we will have good discussions on this, I think. We have recently invested, because we're also an investor in renewable energy tech, in a venture called H2 Green Steel. And that's a Swedish venture that will produce 5 million tons of green steel in Europe, a new steel plant. And here, let's say, when you look at the premium that actually end product costs when you decarbonize the steel, like a car, actually the delta is relatively low, because when you look at a 30,000 euro car, depending on what kind of car you can afford, here are probably people that can afford a little bit more. So a 60,000 euro car, if you pay 300 euro per ton of steel, the premium actually is not even 1%. And we as end consumers can pay for that. So what we're trying to advocate is really what are the end products that we're trying to decarbonize, and what is the premium of decarbonization in the end product, and are we, as let's say citizens, willing to pay for it? Because that's how we can really push like long-term decarbonization.
Thank you very much for that insight already. It gives a lot of connection points to the later discussion. Thank you very much. Roman.
Yeah, thank you. Nice points there, because are customers willing to pay for green products? That could be one of our main tasks. So we are an open die forge, just as Martin told you. 50% of our products are gear wheels for windmills or bearing wheels and so on. So, well, we can profit a little bit from energy change, but we are also a victim of energy change because of massively increasing energy costs. Why is it a problem for us? Well, we are an open die forge, so we have to heat up our material to 1200 degrees Celsius for steel forgings, and we just do it by natural gas fired furnaces. We are not an closed die forging shop, because for automotive tasks you can forge small diameters, small parts, and you can electrify these processes by inductive furnaces, but we can't, because our forgings are very large. The ones for windmills are only 1 to 2 tons per piece, but the bigger ones for ships, for example, are up to 35 tons. And that's not trivial to electrify this process. So, local banks are already watching. Well, one of the points is the electric power we are consuming by running presses and drilling mills and turning lathes and so on is 18 gigawatt hours per year. That's quite a lot. But we're using 200 gigawatt hours per year in natural gas. This makes some 7% of our turnover. And so we can easily see if natural gas has one world market price, and then we turn to hydrogen, and then green hydrogen is 5 or 6 times this price. Our product price will increase in a double-digit way, and I think the gearbox manufacturers as well as the windmill producers won't be willing to pay this as long as our international competitors go on using natural gas with a lower price. But of course we are working and reading very much about hydrogen and alternative heating methods, but we'll discuss this, I think.
Perfect. So maybe to kick it off, and I'm sensing this in the audience. It's already vibrant, and I will take your questions if there are any in a second. Just to kick it off and maybe sort, so to speak, a little bit of the landscape. For me, it would be wonderful to understand, especially to Carina Magnolia, what is your view about hydrogen? And given the fact that we are today in Germany, for countries like Germany, so to speak, with their given energy structure, what is your picture? What will the hydrogen economy look like in the next 10 years when it comes to supply and demand?
Yeah, well, maybe I'll start. Yeah, so when you look at the different forecasts that have been done about the volumes of hydrogen that will be required to decarbonize the European industry, so I'm not talking about only Germany, but the European industry, and we know that we have large industrial sectors in the Netherlands, Germany, and Belgium. So it's anywhere between 500 and 1,200 terawatt hour per year, but most of the studies go around 1,000 terawatt hours per year, and that's about 35 to 36 million tons of hydrogen per year that we're going to use by 2050, according to the different forecasts and studies that have been prepared. Now, today, Europe produces about 8 million tons of hydrogen, so we have to go from 8 to 36. And ahead of us, from 9 to 36 million tons of hydrogen per year. And ahead of us, we also have a Herculean effort of decarbonizing the electricity grid. So at the moment, on a European level, only 1/5 of the electricity that we're consuming comes from solar and from wind energy. So it's very encouraging, but we still have a long way to go. So if you look at the future, we say, well, hydrogen, renewable electricity at the moment is not abundant, it's not plentiful, right? We don't have all what we need to decarbonize the electricity grid. So a lot of countries are looking at imports. For example, the port of Rotterdam, which is Europe's largest port, is at the moment looking at importing 20 million tons of hydrogen by 2050. So it will be a combination of indigenous hydrogen produced in Europe, and also imports of hydrogen that will be required to decarbonize the industrial sector.
Mm-hmm. Yeah, and maybe to add to that, then we have, let's say, the European North and the European South. There's really more of an abundance of renewable energy. So we've recently, for example, spoken to a big Spanish utility, and they were saying, there is enough renewables to decarbonize a lot of the industry in Spain, so they're not worried about the availability of renewable electricity. Same holds true for the European North, Norway, Sweden. There's really hot spots where we still have big capacity, so unused hydropower, for example, that is just, staying there and not being used. But the big question is countries like Germany, as well as the Netherlands, how will those middle countries where we have a lack of renewable electricity, how will they manage? And so there is one solution, which is the import, and Germany is really strong on that. But there's also the option of injecting, let's say, hydrogen in the natural gas grid in a transition phase from, for example, the European South and the European North, and then having it being used in Germany and other countries for example, industrial heat, paying a little premium through a guarantee of origin scheme, whilst we slowly transition to a hydrogen backbone. That is also a big plan, that there is a big European hydrogen backbone pushed by the Netherlands and also Germany that will connect the European countries, where today we have natural gas, and they will be transformed slowly to a hydrogen network. And
this, from my perspective, that's a very interesting point. Is this, so to speak, this hydrogen backbone of, let's say, of pipelines from, let's say, Rotterdam to North Rhine-Westphalia, is this what you believe will come to place within the next 10, 15 years? Or will we have, so to speak, rather the reverse effect, that we have to work more with carbon capture storage, carbon capture transportation, and to make it a bit metaphorical, to say, instead of a European, trans-European hydrogen pipeline, before this is happening, what we rather see is, let's say, blue bulk Linde transporters that are carrying a carbon through on street. What is your best future guess? What will happen in the next 15 years to you guys?
So we believe, but we are also a green hydrogen acceleration center. Mm-hmm. We believe that, let's say, carbon capture and storage is just deferring us from our actual task. Because in the end, I mean, when you look at the volumes that can be stored, for example, in the North Sea, or also offshore, there's a project called Portus, for example, offshore Netherlands. Those volumes, they're still small to the problem we have, and we believe that we should rather put money right now in renewable energy technologies and really accelerating that whole transformation. That's why we hope that hydrogen will mainly be green, and we will use the backbone existent initially through injection. I think that will most likely be the case. We'll see what comes out of let's say, the regulatory discussions. but most likely through injection having a blend, which will allow us to start consuming hydrogen and then therefore bring down the costs. And the blending will be a solution for that.
Mm-hmm. And last follow-up question on that. I understand the vision. I also understand why it's desirable. Is this, from your perspective, can we afford to do it in terms of will we be then fast enough in order to mitigate climate change on the pathway? So will we avoid enough CO2 to release into the atmosphere?
If we don't have CCS, you mean? Mm-hmm. I mean, if you look at the IPCC reports, there's everywhere CCS. As a baseline, we will have CCS, and that will be the case. So we will have certain projects where CCS will happen because there are favorable conditions. Like let's say Portos, okay, yes, that's a favorable condition because it's directly offshore. You have several hundred meters, where you can have a pipeline easily connected, etc. But we don't believe that this is the solution, and we should really push that strongly. We should rather really focus on renewable build-out because that's more what is really hampering us today to have big volumes of renewable hydrogen and bring down the costs as well. Because like 3/4 of the hydrogen price is linked to the renewable energy price. So if you have cheap renewables, you have cheap hydrogen, and you can decarbonize the steel industry.
Magnolia, you were about.
Yeah, so I think what I agree with Karina with the point that renewable hydrogen is like the goal, is like the end goal. But the industrial decarbonization, the situation where we are in right now is not one size fits all. So we need to deploy all the technologies that we have right now in our decarbonization toolbox to accelerate the CO2 removal from the industry. So for example, I do see the use of carbon capture and storage to decarbonize existing hydrogen plants, for example, that they are producing 8 million tons of hydrogen through steam methane reforming, and they are releasing CO2 to the atmosphere. So in that case, can we deploy carbon capture and storage and then accelerate the decarbonization of the industry while we also build the infrastructure for green hydrogen when it's available? So, and then obviously electrification will help with some areas of the industrial sector, like some boilers, for example, that will be. So at this Clean Air Task Force, the way we see it is we need to deploy all the technologies that we have on the table, and there are some areas where it definitely makes sense to use several technologies. And with regards to natural gas and the hydrogen backbone, I think the Dutch government at the moment is looking at that, and they have commissioned some studies, and they would like to get started with connecting this line, developing this hydrogen connected to Germany as well. But also we shouldn't forget that natural gas is also used in the industry as a feedstock. It's not only a fuel, but it's also a feedstock. So what would happen to those users? They will still need to continue using natural gas as a feedstock. So in some cases, carbon capture obviously will be required. And the question is how we close that commercialization gap until green hydrogen is plentiful and available, and then we can switch the system to a renewable system only.
This would be this is going to be an interesting question to our audience. What they think is in Germany politically more acceptable: hydrogen pipelines or carbon capture storage. This is going to be very interesting. Slowly but steadily segueing over to the case of steel, but before coming, so to speak, downstream steel in forging and so on. Let's stay for a second on the proprietary steel production side. You just mentioned, Karina, the example of green steel coming from the Nordics or from countries where energy is abundant. If we look at Germany, energy density, so energy is not so abundant. Now my question is. What does it mean? Either we go left or we go right. Will we have heavy industry in the future, or being not, so to speak, carbon neutral, or will we be carbon neutral but not having steel industry, for example? Is that a tough question to be answered?
That's a tough question to be answered. Yeah. So I think what we're seeing today is that it's true that let's say the basis will shift a little bit. So we see that the countries in Europe that have abundance of renewable energy, they have a competitive advantage. That's for sure. If you are like situated in Norway or in Sweden and you have 1 gigawatt of renewable power, just waiting for you, hydropower that can be base load, so there is a competitive advantage. That is for sure, and that's what we're seeing, in the most Nordic places where no one lives, there all of a sudden is industry settling to build new plants, which poses other questions and difficulties on jobs. Are people there to actually operate those plants? Because who wants to live there? Big question. But I think in Germany, I mean, we have industry in Germany, and it's important also to keep that industry. And then it's about like how do you, on the one hand, try to favor the build-out of further renewables, and there is still capacity in Europe, in Germany. And then the other question is there a way to decouple, let's say, the existing business model of steel? So for example, when we look at the blast furnace, that is, for example, serving like the downstream automotive industry, there today, you have the fully integrated process, for example, and is there ways to kind of split that and create, let's say, the upstream part where a lot of renewable energy is needed somewhere else, and bring those products to Germany, for example, to decarbonize the rest. So there is like ideas around that, how could that be done? But yeah, for sure there is a big question on like how the energy will get there. And then you have another point, let's say Germany is really strongly working on imports, what we said earlier, through also this carbon contract for difference approach, which I think is really smart, and a lot of people are, also other countries are looking at that. France right now is picking up the carbon contract for difference approach, and that is about how to import renewable energy in the form of some kind of molecule, be it hydrogen, be it ammonia, be it maybe methanol even, to Germany, and then use that for our existing industry.
Mm-hmm. And now comes the Gretchenfrage. Will the sorry to be mean. So to speak, the transition phase. If I look to the next 10 years, and if I look, for example, at Roman, what does it mean? So to speak. Will industry or large industrials like Thyssen, so to speak, a company of that type, do they have a fair chance to transition into that, so to speak, into mixed technologies? Because what we are seeing is DRIs and everything is popping up, and everybody basically is running a prototype project or whatever. But the question, so to speak, where's the supply of the fuel comes from? This seems to be a bit unanswered, and my feeling is that the OEMs, they cannot solve it on their own, because a hydrogen pipeline from Rotterdam to Duisburg apparently is a different beast than an electrolyzer in Duisburg. So for me, the question is, in between these stakeholders of, we have the production companies, we have the regulator, we have public interest. What is your best guess? What will happen? Will we get enough supply, or will, so to speak, the industry, so to speak, die slowly or move slowly to a different location? Sorry for putting it so blunt on the table. Moving to different locations, like in the far north, for example, or in the Middle East, because we will not be able to solve that production or supply problem within the next 10-15 years. What's your view on that? And then finally we come to Roman. But I want to get, so to speak, the pan-European view from you guys.
Well, there are a lot of countries around the world that are working really hard to establish themselves as a potential hydrogen suppliers. We've seen Australia saying that they are going to ship the sunshine in form of hydrogen all over the world. Chile has very ambitious plans of exporting hydrogen. So we do see that, and it is very likely that an international hydrogen trade will emerge. And for industrial uses as well. The question is how much is going to cost to move those molecules around, because obviously there's a mature value chain of ammonia at the moment, but it's not being used for the industrial sector. Let's say it's used in the fertilizer industry. So it doesn't seem that it's going to be, because it's not, there's no mature value chains at the moment, like liquefied hydrogen imports and all that. It's not going to be, at least on the short term, very cheap to move those molecules around. So, but also when you were saying about the technology, we obviously need to send the right signals to the market so that investors have confidence in investing in technology, in research and development, and in innovation. And for example, an example is a recent regulation in the Fit for 55 package of Europe included legally binding targets for member states to develop hydrogen refueling infrastructure, right? So that sends the right signals to the people that are making those trucks, hydrogen trucks. So I think the same needs to happen with the industry. We need to create the right policy framework, the carbon contracts for difference, that sends the right signals, and then the industry will be willing to invest because there will be a positive business case. But without the right policy framework, it will be really difficult.
And but by sending these signals, are we good enough on a European level? Are we fast enough in sending these signals so that we hopefully, just like Corona, that we hopefully underestimate a hopefully exponential development curve of, so to speak, technology when it comes to transporting molecules, which is apparently the biggest bottleneck?
Yeah, it's not only on a European level, because the European Union puts together this policy framework, legally binding targets for meeting the climate targets, the climate goals, and we have a framework there. But we also need, as member states, put the right policy framework to go, let's say, to take the next step to make it happen, because like the European Union might say, okay, we need to produce hydrogen, or we have a target of 50% of renewable hydrogen in the industry, but then the member states also need to support that. And just to give an example, the carbon contracts for difference is an example where you can close that commercialization gap, right, and then support the industry to do that. So yeah, we need also the right policy framework at member state level. So the European Union funding and framework is not enough. And an example is the STE++ policy mechanism in the Netherlands, which incentivizes and subsidizes decarbonization technologies, and that's part of the Porthos project, where carbon capture and storage will be used, but also renewable energy. So that will make projects to move forward. So that's an example.
Okay, so there's hope. Now,
now back to reality.
Back to reality.
Problems in small.
Exactly, back to reality. Having heard all that, how does that feel?
Yeah. First of all, renewable energy in Germany is quite a problem, because if you have a look at the figures, first half year in 2021, we have only 42% of the electric power supply renewable. Last year it has been 50%. So we have this sad word of Dunkelflaute in German, dark lull in English, because, well, Remscheid, the city where babies are born with an umbrella because of very much rain and not very much sunshine, is not really the example for photovoltaics. And, well, we have some wind power in the north, offshore, in the North Sea, but we have large political discussions about building electric lines to southern Germany, where most of the industry is located. So we are not able to build up these electric power supply lines within nearly decades, even years. And so it's quite difficult to think of some hydrogen lines being placed in the nature or through the cities or wherever, even thinking about this chemical experiment, just lighting up some hydrogen. Just if you imagine what is hydrogen, and is there some danger and so on, and what do we have to think about? So if you have a look at the gas supply in Germany for industry or for houses, in earlier decades, we already had some hydrogen inside our natural gas. It was called city gas. It contained up to 50% of hydrogen. It worked, of course. You don't want to see the prices for a new city gas with 50% of hydrogen, just regarding the world market price for natural gas and the hydrogen prices. Could be interesting where the price would be located. On the other hand, think of all the heating devices in all the houses, and you have to change all the heaters burning gas to a gas hydrogen mix. Quite interesting. For me as an industry plant, we could change the furnaces to hydrogen if, first of all, the burner technology is not yet developed. It's existing on the laboratory scale, but in industrial scale, burners of larger than 1 megawatt power is not yet on the market. Second, the amount of hydrogen, well, I had some calculation. If you just think about 200 gigawatt hours of natural gas, which is needed by us, we would need some 6,000 tons of hydrogen per year, or 20 tons a day. Just back calculated, I read something about the largest electrolyzer for green hydrogen built up by Siemens in Wunsiedel, I think. Has a power of 8 megawatt. I calculated we would need some 30, so we take 4 of them. Quite interesting thought. 30 megawatts electrolyzer power. Investment of larger than 30 million euros. Okay, place 30,000 square meters. Interesting if you read these figures as just an industrial dinosaur.
But I really think you're touching on a really important problem, because today, you know, everybody's starting to talk about gigawatt scale of electrolyzer. You know, really, like seriously, they talk about gigawatt scale. If you look at the biggest plant in the world, is 20 megawatts.
Yeah.
Megawatt.
So, and we need 30.
Exactly. And so, you know, there is really a mismatch between the hype that is around hydrogen now, and what is actually going on in industry. I mean, like if you want to scale from, let's say, there are a lot of plants that are around 1 megawatt, 2 megawatt, that is, we can handle, and then there are maybe 2 or 3 at 20 megawatts, and that's it. So scaling that up, scaling also up the manufacturing capacities. Today, there is not enough manufacturing capacity. Yeah. All the big hydrogen electrolyzer producers, they're now talking about we're setting up gigafactories in Spain, in Sweden, everywhere, but they're not set up yet. And that takes time also, and we have not done that at that scale. Today, honestly, there is people that do that manually, that put together the stacks manually, put one stack to another, and try to build up a megawatt like this. You know, so there is really a big mismatch on that.
Yeah. And you can't simply use natural gas pipelines for distribution of hydrogen from Scandinavia, wherever, from Northern Africa, wherever. On the other hand, just looking at our plant, the burner technology, okay, the hydrogen capacity is quite a point. The economic side, well, hydrogen, green hydrogen, is more or less 5 or 6 times the price of natural gas. Well, we can't do this change without increasing our sales prices. And all our customers just ask, what's your decarbonization strategy? Is it located at top management? Yes, fine. And we say, okay, we can change to hydrogen if we have burners, sufficient hydrogen, and so on. And then we will increase our prices by 40%. Oh, no, you can't increase your prices. So serious, what can we do? And then we have a technical problem, a little one. If we had these burners for pure hydrogen, the flame temperature is rising a lot to more than 2000 degrees Celsius. It's not unhandleable, it's possible. But the problem is, with a higher flame temperature, we will create nitrogen oxides. And this will be the next discussion point. Next to carbon dioxide, then we have nitrogen oxides. Mm-hmm. So we need not only hydrogen, but also oxygen for oxy-fuel burners. Mm-hmm. So then, you know, one possibility we have next to the natural gas pipeline, a hydrogen pipeline and an oxygen pipeline, or we just build up this small 30 megawatt electrolyzer next to our plant. Unfortunately, taking 20 tons of hydrogen per day, and if we store only a quarter of this amount, only 5 tons of hydrogen on our own plant area, our character will change to a critical incident company, like a chemistry plant, because of, you told it yourself, hydrogen is explosive if you mix it with hydrogen. If you store 5 tons, it's, well, if you have an incident, then the motorway A1 ends in Remscheid.
I think this is very nice. Very nice. Put the dimensions on the table, and not to forget, so to speak, the energy needed. That is behind the 6 tons of hydrogen. If you calculate, so to speak, 1 megawatt of wind generates 100 kilo per day in that area. That gives, so to speak, a dimension what's behind it. So the question, or how does it feel? Looks quite impossible, so to speak. If you take all that dimensions, it's a bit seems to be a bit frustrating. The question now is what can be done, so to speak, and that's maybe a little bit of a German problem. We are imposing KfW 55 standards and are wondering why the budgets are never withdrawn, because we put standards so high and forget, so to speak, a bit the 80-20 rule below that, what could be done, what is already effective and brings us a good step in the right pathway. But now we are focusing on meeting that standard and are wondering ourselves that the budgets are never being withdrawn or used. What is, so to speak, from your perspective, the things, switching mindset and getting a let's get it done mode? What are things that could be done today in order to make a good step forward by saying, well, doing PPAs and buying, so to speak, green energy, having a scheme that, so to speak, end customers pay on the product, but not, so to speak, switching mindset from imposing a price on the for product or the pre-product to the end product. What is, so to speak, that you need so that you need to change, but what you also what would you need from your subsequent clients in order to make a good step in a more decarbonized direction?
That's a wide field. Well, one first point for the rules, political rules, which are pending. We have some different laws, fees, taxes for renewable energy. Mm-hmm. It's in Germany EEG, Umlage, fee, tax. That's a fee which is in the size of, or dimension of 6.3 cents per kilowatt hour, which is nearly the same as the production price of electric energy. That's quite interesting. Not to have some carbon leakage, the German steel industry, because there you have to distinguish. You have the recycling route with electric arc furnaces, scrap plus electric energy makes new steel, or the blast furnace route, iron ore plus coal or direct reduced hydrogen for new steel. Therefore, you have the so-called besondere Ausgleichsregelung. It's a special. Does everyone speak German? Oh, it's a special tax relief scheme in Germany, so that the steel plants, for example, the very electric energy intensive industry, has a chance to survive in Germany. So politics has the possibility, the risk, to just kill this industry just by dropping this rule of besondere Ausgleichsregelung. Then I would be able to name a couple of German steel plants which would be dead immediately. We have the new Brennstoffemissionshandelsgesetz. It's another carbon dioxide fee, which is in the dimension of 25 euros per ton of carbon dioxide, increasing to 55 euros per ton by year 25. Just for our example, we are not profiteur of the besondere Ausgleichsregelung, so our forging shop pays 1.2 million euros for EEG, renewable energy tax, and this year another 900,000 euros for the carbon certificates, or the BEHG. Also there's some carbon leakage relief scheme, but it has some different rules than the CO2 certificates of European level, so we can only get a relief of maximum 49%. That's quite interesting, that's quite nice, but it still is some extra tax, extra fee, which we will have to pay in comparison to our Italian, Indian, Chinese competitors. That's a problem. And another problem by politics is these carbon leakage BECV has some condition. If there's not enough money in the German national etat, then it's dropped. If there's not enough money, then the companies won't get this relief. How do we want to plan with this legislation?
So
and if you just go on looking at carbon contracts for difference, I calculated this. Take 200 gigawatt hours natural gas. I don't want to say our actual price of energy we have to pay, but for example, take 3 cents per kilowatt hour, and green hydrogen 16 cents, 16.5, would be a little difference of 25 to 28 million euros per year, which would be needed as a contract for difference every year.
And how much is that on a ton of steel?
In tons of steel?
Per ton of steel, for example, produced?
We are not producing steel. We are not a steel plant.
We are
only a Ford,
but
we just handle, depends on the year, roughly 50 to 70,000 tons of steel per year.
Okay.
If you just calculate it in another way, if you take green hydrogen, the extra cost. Sorry, one sentence. The green hydrogen would mean an extra cost of roughly 700 to 800 euros per ton. Who wants to pay for it?
And that's, I think that's the crossover where you were segueing. The question is, do we find it on a different level of understanding, so to speak? Is there willingness to pay, or is there an imposing regulation to say so to speak, this price has to be paid by the end customer on the car rather than on the ton of steel? And that's probably a question which policymakers should consider in order to make a step forward. Because if, so to speak, everyone in his corner cannot possibly solve that without losing all competitiveness, and that has become very apparent.
But for example, what we see in this project, let's say in Sweden, I mean, they have already, let's say, signed off-takers. There is a premium. I said like more than 100 euro per ton. It's between 100 to 200 euro a ton, which is a lot. It's really a big premium for those kind of steel products. And they have signed off-taker agreements with Daimler, with Scania, now recently with BMW, that are looking for green steel. There is a need in the market for green steel. And that, I think, is sometimes overlooked. There is a need, but it's true that, let's say, existing industry takes time for the transformation. There are also really hindering points, like you said, on technology, etc. So therefore, I think this project there really shows that there is a need for green steel, and this premium, can be absorbed by the end customer, and those car companies or automotive companies, they believe that they can pass it on. And if you look at, for example, their transformation strategy, all of those companies, also like the utilities now, they have net zero targets, 2030, 2040, 2050, whenever, but most of them have it today by 2030, 2040. That's around the corner today. So they need to assure already today that the products also that they're sourcing, not only their scope 1, scope 2 emissions, but also the scope 3, where the products that they're sourcing, they become greener. And so we believe that there is a lot of actually unlocked market demand actually in those areas that are not looked at and where the premium can be passed on. And so let's say the mindset sometimes we believe has to change. When you look at this Swedish project, it was, let's say, kind of an open book approach. It's also a bit crazy because this is really business model, let's say, disruption, I would say. Where you look at, let's say, the upstream part, say, okay, how much does it actually really cost to produce a green product? Really, how much does it cost? And then we look at how much margin do we need to make this bankable, to get financing from banks, etc. And then how can that be transformed to the end customer? And then they jointly, throughout the value chain, co-create that new project. And that's a different approach. Yeah? We do the same thing, for example, in the fertilizer industry. When we look at their same problem, we can use green hydrogen to replace gray hydrogen to produce green fertilizer. And then the question is, okay, how much would it be if you use today green fertilizer in the end product, like let's say a beer that is decarbonized, or let's say feed for animals that is decarbonized, to understand how much does that premium cost, how much can we decarbonize, and are those end customers willing to pay? Because today those two, let's say, sectors, they don't talk to each other. The energy sector doesn't talk to the food sector. It's really hard to make, and we're really trying to make those connections and try to create the links. And I think there's really like some kind of business model innovation also to be done. Mm-hmm. And we're still at the beginning there, but I think it's worthwhile doing it because,
I think that's a very nice statement because it brings us back to the very beginning of it. Our human brains, we're not very good in collective thinking, and this is just another application of it. We try to impose, so to speak, the burden of windmills, of shipping, of trains, of everything that's rotating made of steel and that's pivotal to get things rotating. We try to impose, so to speak, the burden of carbon on that industry because it happens to be there in terms of proportionally there's the energy spent, let's say. And we don't recognize, so to speak, the layer of different products that are and services that are on top. And I think here a mindset shift is necessary because it has become quite clear, so to speak, on the level of a steel maker producing company, so to speak, the problem of an entire country cannot be solved. And that's I believe that's the truth, but that makes also hopeful because what I'm seeing is that behavior is actually changing, and the twin discussion to the discussion we're just having is on e-fuels and aviation. And of course, people are saying, well, is a family that goes on holidays, will this family be able to pay a carbon price for that holiday trip? No, most probably not. But corporates will do. Because corporates want to have green aviation and they want to have green mobility because it pays into their image, into a whole lot of things.
And their shareholders. I mean, they've
exactly.
promised they're carbon neutral now. They cannot go back.
Exactly. And I think that's a mindset thing. Where do we start that discussion? Do we start it at the ground level, or do we start it, let's say, on a more collective level? And I think that's a transformation that we as a society have to undergo. Now, time's up, but I have these two questions for you still, apart from your own question. First of all, I want to know who believes that we have a hydrogen pipeline by 2030. Hands up. That's interesting. Who believes that we will have a CO2 pipe, so to speak, instead of having hydrogen coming from Rotterdam to Duisburg? Who believes that we will have a CO2 pipeline going from Duisburg to Rotterdam? Just thinking that. Okay, that's rather the minority. Interesting.
Depends on where is the hydrogen pipeline going to? Is it going to Remscheid city? No. Quite sure.
Interesting follow-up. Yeah. So open, so to speak, to the audience, receiving your questions. there are any.
Yeah,
Oh yes, in the light. Sorry, I didn't see it.
Yeah, I would be interested in, you described very well the problem you have in terms of alternatives for heat as one of the key factors for you to take any decision. What options have you actually looked at besides hydrogen, and what was the menu of options you looked at? It would be interesting to understand a bit from what angles you've looked at this already.
Yeah. Well, in history, we've always been looking at energy. For example, we are running steam-driven hammers, and we started with coal for the production of steam. Then in the, I think, 50s, we changed over to heavy oil, and in the 70s, we moved over to natural gas. In the field of furnace technology, or burner technology, we have to save energy. That's the most important point. We have some energy management system according to ISO 50001. And so we are using recu burners. So we use the off-gas residual temperature to preheat the burning air. And there you have different technologies creating 400 to 600 degrees per year. So these departments do not talk to each other. So this is quite a problem.
Okay,
so but standing still obviously is not an option. So you must be finding common space, right? I mean, there's
but the point is, we can reduce our electrical consumption by using more efficient machines and pumps and whatever. We can cut back our natural gas consumption, more efficient burners, preheating and whatever. But if we change from natural gas to hydrogen for immediate decarbonization,
not an option.
this is just a black and white decision, just on-off. And then we have a completely different scheme of costs. This is the large problem. So we need, first of all, sure available technology. We would have to set up a complete new infrastructure in our company, because the natural gas pipelines, did you hear about hydrogen embrittlement in steel? That's quite a fine thing. Because if you have some direct reduction and so on, or just any other steel making processes, one of the worst elements inside the steel, inside the material, is hydrogen. Because if you have too high hydrogen amounts inside the steel, it will fail brittle. So that's quite also in piping and all the valves and so on, very interesting. Natural gas as methane, CH4, is much bigger than H2. So, are they tight, the valves? Or do you have to replace all the infrastructure? Quite interesting. Also in our company, and we would have to build up an oxygen infrastructure, new furnaces, new steerings, and so on and so on. That would be quite a large effort. And then the running costs after this investment, electrolyzer, don't know, 20, 30, 40 million euros. Your infrastructure, 10 million, I don't know, not yet checked. And then running costs, and then it's decisive, is it possible to cut back the production costs of green hydrogen to more or less the level of natural gas in the world market price? Because our competitors will go on using natural gas as long as it's possible, because it's a lot cheaper.
But then, so to speak, from here, zooming out again, and there was one brave person in the audience to say, well, there might be CO2 pipelines, so to speak, at least maybe for an intermediate period in time, and it hints here a little bit in the direction of, is the black and white decision, is it, so to speak, wise to take or even possible to take in the short term? Maybe difficult. I think that's what came out quite clearly. Carbon capture is maybe something that we need to accustom, that we need to deal with it, at least for the next 10, 15 years. And then in order, coming back to the beginning, just to not ideologic but logical, just to get it done. We are a bit running out of time. So I think we need to go, and I can feel it's so to speak a little bit of nervosity already. Let's take on this discussion to the beer tables later on. It's been thank you very much for participating, for being so vibrant. Thank you very much for that. Thank you very much. Thank you.